All right, so this week we are going to focus on two chords that are in a circle and how their measurements are related. So, as a review, remember a chord in a circle is a segment that starts and stops on the outside of a circle, on the edge. So, we have in this circle, we have chord AB. And we also have chord CD. So we're specifically talking about two chords in a circle. So the way it works mathematically is that the product of each of the parts of a chord are equal to each other. So if I put numbers here, let's make this 1, 2, 3, 4. I don't want you to get attached to what the numbers are. I want you to look at the parts that I'm keeping together. So we need to keep EA times EB. So these are both on the same chord and they go on the same side of the equation. So EA is number 1 and EB is number 3. So I've got 1 and 3. See how they're both parts of chord AB, so they need to stay together. It doesn't matter if I would have put 3 times 1 or 1 times 3, but they are together on the same chord. And on the second chord, CD, we've got EC times ED. So EC is 2 and ED is 4. So 2 and 4, those are both on the same chord and they go on the same side of the equation. Okay, and so that's the relationship. You want to multiply the parts of the chord and they need to be equal to each other. So we're not saying that the chords are the same length. We're saying the product of the chords are the same length, okay? So let's see how that works. So let's look at the first example. And I'm going to kind of even just keep the parts together and not focus on the names. So I just pick any chord. So I've got chord AC. I'm going to circle it in red. I've got part X and 10. So those are the two parts of the chord that I want to multiply together on the same side. Then on the other chord, BD, we've got 5 on the left and 14 on the right. So we're going to multiply those together. Now, this is an equation, and we haven't dealt so much with the equations this quarter, or year for that fact, but we can do that. So let's keep x times 10. You can write that as 10x, or you can leave it alone. And then let's do 5 times 14. So 5 times 14 is 70. Now, to get x alone, we always want to do the opposite math operation. So by the x is a 10, and it's being multiplied. So the opposite operation is to divide by what you want to get rid of. So I'm going to divide by 10. So those are opposites. And we have to do the same thing to the right side. Divide by 10. So x is on the left. And 70 divided by 10 is 7. And so that's the missing length that we found. Okay? Let's look at another example. The more you do, the more this will be familiar and you'll understand the process of solving. So let's look at chord DB. So we've got 14 and X together. And on the other chord, we've got 7 times 12. So I can leave the x side alone, so 14 times x is going to stay. And 7 times 12 is 84. So once again, if we want to solve, we're concerned with the side that has x on it, and we want to do the opposite math operation of what we want to move. So we want to move the 14, so we divide, because that's the opposite of multiplying. We divide by 14 on both sides. So x equals 84 divided by 14 gives us 6. Okay, so we can have decimal answers, and that's fine as well. Let's do a third one. So let's go ahead and multiply these. So we've got 6 times 14. And then on the other chord, we've got 7 times x. So 6 times 14 is 84 equals 7 times x. So once again, to get x alone, we want to move that 7. It's being multiplied, so we divide by 7 on both sides. So we get 12. And that's the missing side. And let's try one more example just to make sure we have the idea. So we've got 12 times 6 and x times 8. So 12 times 6 is 72. We want to focus on the side that has x, and so we want to move the 8. It's being multiplied, so we divide by 8 on both sides. So x equals 9, and that's our missing side. Okay? So go ahead and give your problems a try and let me know if you have any questions.